Hello all. Welcome to another video of Data Science with Julia. This time we'll be looking at fitting a curve with genetic algorithms. So let me just take my blog and other stuff and show you. Okay, so yeah, this is Data Science with Julia, and right. Okay, so we first did guessing a number. So number is just a scalar with just one dimension and all those stuff, and we just guessed a number with uh, what to say with a genetic algorithm. Now what we are going to do is we are going to fit a curve. Curve means like this is not a very fancy curve or something like that. All I'm just going to do is like fit a line to a set of points. So you have set of points like the line is 7x plus 5 and I'm just going to fit a curve, right? So for that, so we are going to see how we are going to do it. Okay, so it's I don't know whether it's simple or not, but before you, if you're landing on this video, yeah, do visit blog for this video, read this guessing a number with genetic algorithm, or visit this video and all those things. I'll try to give all these links. So I'll try to give all these links in my video description, right? So yeah, let's try to fit a curve and let's see how it happens. But before that, yeah, let me say how genetic algorithms work this time. So, okay, right. Okay, so I'm just creating a simple diagram, right? So let's create a graph, right? So, okay, right. Uh, Okay, I'm just trying to put an optimal size of this page, but it just keeps going. So let's try to create a graph. So you have this x-axis over here, and yeah, it goes like this, and then you have this y-axis, kind of perpendicular. I hope I can draw perpendicular line properly, right? So this one goes like this. Let's make it bigger. And you have a line, like imagine like some line, right? Some line over here. Let's say this is the target line and let's make it some color. So that let's make it some kind of red or something. Yeah, it's red, and let's make it bigger, like that is like thicker. Yeah, because like I just want it to be more. Okay, so this line is being guided by two constants, like two constants define this line. So actually, before we guess just one number, now we just need to guess two numbers. So now you see like how this has been related with guessing a number with genetic algorithm. So this has been guided by two constants. Okay, one is the slope. Slope is nothing but this one. Like let me just put it as okay, 3, 2, 1, and let me make it something like gray or something, right? Like, I don't know whether it's okay. Yeah, fine. Slope is nothing but for this much increment of x, okay, how much increment of y you have, right? For that you are having okay, and paste, right? For that you are having this much increment of y. So slope is nothing but okay, y by x. So the vertical by this horizontal, right? That is slope. Okay. So that has been represented by a character called m. Okay, so that has been represented by a character called m. So let me just put it over here, m, right? So okay, so oh god, why it is like this? Okay, we try to put a free text. Okay, so this is the m equal to y by x. I don't know how to put divide and all those stuff. Okay. So this is the slope. Okay. So that's the thing. So y is the vertical axis, x is the horizontal axis. And you also have another thing called C. C is nothing but the place where it intersects at zero. Like when x is equal to zero, y this line intercepts at a point called C. So this is the point that is called C. Okay, let me try to put C over here as a point or something so that you people can see. Oops. I'm not really good at all this graphics and stuff. You can't. Okay, I don't want to say I'm not good at. Sometimes I'm good at something. Sometimes I'm not good at something. So this is the point at C. So actually, it is like this point is 0 comma C. Okay, to be precise, like 0 in x-axis, C in y-axis. So this is the thing. And yes, this is the x-axis. This is the y-axis, right? This is the x-axis. This is the y-axis. Hmm. Okay, so actually just two constants define a line, right? And that's it. Like this is a very, very simple equation and all those things. So this is a line. So let us see how our algorithm works. Okay, so what our algorithm does is like, okay, it takes some value of m and c. Let's say it takes this is the value of m and I just want to make it like some other color, right? So blue color, okay, right? So blue color, okay. So this is the first line it has, okay, and let's say this is our first line and something like that. And now what it does is it creates two other lines, okay. So let's say like one line is like this, slightly goes away, okay, right? Let's put it as another color, right? Yellow, right? No, yellow is not so visible. So let me put it as okay, dark yellow. Okay, something like dark green. I don't like dark green for some reason. Dark yellow, yellow. This one. Okay, yellow and green are kind of mixing. Okay, okay. Let it be yellow itself. Okay, yellow line. Okay, because I'm going to delete it in the next process, next step. Okay, and then yeah, we are just putting another line over here, right? So this line, let it be like, okay, like orange or something, right? Okay, so if you look, which is more closer to this line, okay? If you measure the distances, like, okay, a point over here. So you just put a vertical line over here, right? Anywhere, okay? I'm just putting it over here, right? So I'm just putting it over here, and I just want to keep it as full black. Okay, so the distance between this and this orange line is smaller. And okay, so this is the initial line. This is the mutated line. So you change M and C and you get this orange line, and you change M and C. Let's say, like hypothetically, just for the sake of explaining, let's say you just mutated this and got two other lines. Okay, so you just got them, and what happens is like, okay, this orange line is far more near to what to say, this one, like this red line, that is the target line. So what happens is these two lines get deleted off, right? So these two lines get deleted off. So deleted, deleted. Okay. So from now, let me put this orange itself. So now you mutate this orange line. Okay. I just mutate and I get another line, something like this one. Okay. Right. And another line, I just get something like this one. Right. Okay. So looks like, okay, these two orange lines are far away from the red line. Okay. So that's how it is. Like it is measure of distance and what to say, taking out. So slowly this orange line moves, and it finally joins this, almost joins this red line. Okay. Or if you think like, okay, this red line you can represent as set of points. Okay. So set of points means, okay, this is another point, Another one. Come on. Let me just remove this orange line. Okay. Now I'm just putting 3 points. Okay. So, why this point has divided this line? Okay, fine. Very pathetic. Okay. So this orange line slowly just moves, tries to matches this set of points. Okay. So that's how this thing works. Okay. So this is how guessing a line, or you can even do it for quadratic equations as well. But for quadratic equations, you need to have three parameters because it's ax squared plus bx plus c. So line is just y is equal to mx plus c, right? So that's the thing. And yeah, so we are going to fit a line to set of points. Okay, so that's what we are just going to do. So let me just come to my blog and let me just start my notebook. So here is my notebook. So let me just put it over here. Okay, curve fitting. I don't know to call it curve fitting because line is technically a curve that has no turnings. Okay, so but yeah, curve when you say in human terms, it turns. Okay, so but yeah, like I think it's quite accurate topic and all those stuff, or at least a catchy topic that gets more YouTube hits and all those stuff. So curve fitting genetic algorithm. Okay, so we are just having this. So first we just put a line. Okay, so like 7x plus 5. You can put any constant. It doesn't need to be just 7x plus 5. I'm just putting 7x plus 5. I don't know why. Right, and we just have x as range like 0 to 5 and it's steps of 0.1, right? Okay, right, and I think next we are just plotting. Okay, so we are just using this plots. I hope you have installed plots, or yeah, or you need to install it. So please go and read plots in my blog and all those stuff. So we are just plotting. This might take time. I don't know why, even though this is mine is Mac M1, it is taking time, right? And yeah, just see next one once it's okay. Yeah, the plot ran and all those stuff. So you're just getting a string of points, okay, or a nice line of points, okay. So that's the thing. And I just need to tell one property. I think I would have told it in tuple section. Otherwise, just go and look for videos in tuple, like tuple and Julia and all those stuff. You can find it in this playlist also. So okay. So the thing is like okay, you have what to say a tuple over here 5 comma 7, and you just assign it to m and c, right? Just like that. And when you just split it out, m becomes 5 and c becomes 7. So this is a property of Julia. I think it's called unpacking or something. No, I'm not sure. Like, but yeah, like I don't know what's the technical term. Okay, so the next thing is like we put a thing called mutate. Okay, so okay, this mutate is from the last thing where we did guessing a number with genetic algorithm. So if you just give a number, and this mutate, what it will do is like this will just mutate into 10 values. Of course, you can mutate to many, but the thing is like, okay, I'm just giving like 5 and it just mutates. Like, okay, so what's happening? Okay, we just give it. Okay, but then why it is not? Okay, fine. I'm not sure why it's not working for this. Okay, yeah, anyway, I think I need to debug it. Okay, so that's the thing. And okay, mutate 5. Okay, and I think I need to give something like okay, mutate 5 comma 5. Okay, so it'll or like 7 or 17, right? So it'll give 17 mutations for 5. So okay, I'm sorry, like it shouldn't be like mutations is equal to 10. It should be 5 comma 17. So 5 is the number that needs to be that needs to mutate, and we need 17 mutations. Okay, so that's the thing. and we write a function for a tuple mutation, right? So what it does is, okay, I'll just explain, right? So a tuple means, okay, we have something like, okay, let me just, okay, let me put it like, okay, let's initial m and c values be 2 and, okay, like 8 and all this stuff. So what it does is it mutates the first thing around 2. So it's 1.9, 2 point something, 1.7, all those stuff. And second thing is mutates around 8. Okay, so and it gives 10 values. Okay, by default it's 10. So what happens is, okay, as I said, like this M and C, right? Like we are having this property M and C is equal to 5 comma 7 and all this stuff. So this 2 and 8 goes to this mutate tuple. Okay, Julia knows. So like this is it's called as multiple dispatch. Please do read about multiple dispatch or watch my video about multiple dispatch to know about it. So Julia knows we are mutating a tuple because of the type over here, right? And it goes over here, M becomes 2, C becomes 8. Now 2 mutates 10 times over here, or number of mutations over here, okay, right? Whatever it is. By default it's 10, okay? So 2 mutates to all these values, okay, like all these values over here, what you can see it in the left side of this tuple, that is vector of tuples, okay. And then similarly, what to say, this 8 mutates to all these right hand side values, okay. And all we just do is like with list comprehension, I think in Python we call it as list comprehension and all those stuff. We just put it in, what to say, a vector of what to say, tuples, and we just return it out. So that's how this works, right? So yeah, so this is how we just mutate and all those things. Now we need a way to select the top, what to say, the nearest line. Okay, so nearest line means, okay, right, this one I've messed it up. Okay, so we have okay, right. So just remove this point, and we have, okay, the first mutation might give a line like this, the second mutation might give a line like this, that's really far away. The third one might give something like this, right? And it looks like the third one. Okay, so that is the topmost line is the nearest to our target grid line. So our top servers function will just kill all others, and it'll just keep the one that is just nearest to the red line. Okay, so imagine this line should actually extend to infinite value. Okay, it should keep on going. So that's the thing, right? So that's the thing. Okay, so uh, so what we do is like we have first an error function. So any line, okay, even this line, right? This line, it's been given by mx plus c. So we need to compute these errors. So error over here will be this much. Error over here will be this much. Error over here will be this much. So let's say like we just have like 10 points or something like that, okay, given us training x and training y's. Okay, training x and training y's are nothing but, okay, this is not coming exactly, but yeah, I think you get the point. Okay, so training x and training y are nothing but the points over here, this xy, and if we have another point, this xy, and if we have another point, this xy. So we need to compute errors for all these points over here. So for this it will be this, and for this it will be this. Okay, so we are just computing the distances between the target line and the mutated one. Okay, so we are just keeping a function like error function where we'll be passing our computed what to say, our m and c. It will calculate mx plus c, okay, and it will minus from the y. The x and y are nothing but training values provided to us. Okay, so let me just put this error function, right? Okay, so we just get it. Okay, not a problem. and we are just doing it for 5 and 4. Okay, and we are doing y of 10. So y of 10 means y we have defined it over here. Okay, so 10 will be 70 plus 5 is 75 and something like that. Okay, so okay, so okay at x is equal to 10 and y is equal to 75, there is like round about like 21 steps difference, or 21 units difference between our 5 comma 4 or like 5x plus 4 and 7x plus 5. Okay, so that's the thing. Okay, so we need to calculate the total. Okay, so like what will happen is, okay, like let's say like we have a line like this one. Okay, so okay, and it goes something like this one. Okay, so it goes something like this. Error. Okay, let's say like we are doing this minus this blue dot to this orange line. So now if we do over here, if we just extend it indefinitely and do it, this orange line now is above this blue dot. Okay, so if we just extrapolate this, okay, or put this line over here, right? So now this blue dot minus orange line will be, the error will be reversed. So you're going in this direction, right? So orange line is more. So let's say like this blue dot is at uh, 20, and this orange line over here is at 35 or something. Okay, so what is 20 minus 35? It will be minus 15. Can error go in minus? I don't think so, right? So error should always be a positive value. Error is the deviation, not just the deviation, as the is the absolute value of deviation. So while we are computing this total error, we are taking that into account. Like so, let me just explain to you what it is. Okay, so uh, we have m and c values, and we'll have an array of x and array of y's. Okay, so those are all the points. Like array is nothing but the training points, 1 2 3 4, right? Those training points given to us. So we'll have 4 x values and 4 y values. Okay, so now the total error, we are just having it like sigma of delta. The sigma I think can be written like, okay, like you can write it like sigma, right? Okay, and delta can be written like delta, right? So I'm just using it to represent this total errors, and first it's 0. So for every value in okay, for 1 to number of elements in x, and number of elements in x should be equal to number of elements of y, otherwise this algorithm will might not work right. Okay, so that's the thing. What we are doing is like we are taking the error of the absolute error of, okay, this one mc x and y as defined by over here, right? So and we are just putting it to this sigma delta, and we are finally returning this sigma delta. So that's how we are getting total errors. So we'll just test this total errors out, and so I've explained how to calculate. Yeah, so for 5 and 4, okay, lines 5 and 4, okay, and okay, 5 and 4, let's say a line is there for 1 2 3 4 5, and y is also 1 2 3 4 5. So let us compute the total error. So it's round about 80. So yeah, fine. So that's the thing, right? So we have got total errors over here. So all we need to do is to do this top survival. So as I said, what the top survivors will do is it will find which line deviates less from the red line. So I think this orange line at the bottom deviates less. So what it will do is like it will delete this one off. Okay, so that's what it will do, right? So, but yeah, you will have a lot of m and c values, and it will pick only the best or top percentage or top 10 percentage. Okay, so we are giving, I think, 10 values of m and c's at first. So and so top 10 percentage means it will just pick only one, right? So that's how it is, right? So yeah, we have this errors and values. So we'll collect errors and values in this array. If you're not understanding this, please do read this guessing a number with genetic algorithm. So please, that's how it is, and know from that. For every value of m and c, we are computing errors, the total error. Okay, so over here, the total error, right? And we are pushing the error value as first value of the tuple, and Okay, we are pushing what to say for this array. We are creating a tuple with error, that is this error, and the MC. The MC we are getting over here, right? And we are just creating a tuple where array and value tuple. Sorry, error and value tuple. Okay, and it's been put into a array. So array of error comma value. So it will be something like an array of error. Okay, and then one MC. And similarly, this will just go on, right? Next, there will be another tuple. So error 2, and then let me put something like M2C2. So that's how it just keeps on going, right? So let me just put new lines so that you can understand, right? So this is how it just keeps on going, and next one will be M3C3 and all those stuff, right? So let me just put it as raw so that like okay, and okay, error 3 and then comma M3 comma C3. So this is how it will be. So this is how this data structure will be. So we are just building something like that. Okay. And now what we are doing is we are just sorting, and we are just taking the n number. Like let's say we give 10 values and the n number should be 1. So the sorted errors of this thing is like the first value should be taken. Okay, so that's it. Yeah, you can give hundreds of MCs, not a problem. So it all depends on how you want to do. I just want to. This is just a video to explain about genetic algorithms. Okay, so nothing else. So let's have a initial values. So I'm just having like x is equal to 1, 2, 3, 4, 5, just 5 points. And y train is y dot of x. So it'll y dot of x is like y of 1. So what is y of 1? 7 plus 5, it'll be 12. Okay, so and all those stuff. So that's how it is. And what is 7x plus 5 of that is y of 2, like 14 plus 5 is 19. Okay, so that's how it will be. So similarly, for all these values it will be computed. And now you have this MCs is I just mutate 0 comma 0 and have it like initial MCs, so it will be around about like 0 0. Okay, so that's how it is, right? And what I do is like for 40 generations I just want to see like what happens. Like so for 40 generations, okay, so top survivor is first nothing, MC is 0 0. Okay, so first I'm just mutating this MC, right? And then and X train and Y train will be taken from this one. Okay, so that's the thing, this cell, right? So top survivors is equal to top survivors of MCs X train Y train of 1. Okay, so I think we are just taking the first value. So that's the thing. Okay, we are only dealing with one value. Okay, so over here we have just hard coded 1 or something like that. We just want only the topmost survivor. Okay, this error I'm not using, so I've just put underscore error. So finally we just need only MC, right? And I'm just taking MC. So top server will be this thing error and okay, let's see the error 3 is the top server. So it will be error 3 and M3C3. So this is the second value in tuple. This is the first value. So the error will go into underscore error and it will just be discarded after this loop. After this iteration of loop. And M3C3 will be stored in MC. So that's how it is. And once again, when it comes out here, it will go to this MCs. It will mutate and it will go to top servers. The top server will be picked up. So now I'm just having like okay. Now the topmost MC will be stored in this MC, right? So this MC, it would have iterated away from 0 in 40 generations. It would have iterated away from 0. So I'm just having like HM and HCs. So usually we'll say hypothesis in machine learning as H. Okay, so I've just put like okay, hypothetical value of M and hypothetical value of C as MC. So it'll have like okay, let's say like M is like 6.4 or something and C is like 4.9 or something like that, then this will be 6.4 and 4.9. And I'm just putting a scatter plot, okay, of X train and Y train, okay. And then I'm just putting this one, what we have predicted, and I'm just plotting, right? So let's plot it for 40 generations. Look, and it almost matches this line. Okay. So if you want to see something graphical, that also I've just done, we just put like something like a thing called GIF. Okay. So and look how good it just plots. Okay. So all we are just doing is moving this plotting stuff inside this loop. Okay. And we are just saying that generate a GIF, whatever is the output of the loop. Okay. So the output of the loop is nothing but we first scatter plot this one. So we just put these dots over here, right? And then we just plot our line over here, right? And we just set 0 to 50, because if you don't set y limits to 0 to 50, I just saw the plot being jittery. Okay, so that's the thing. And you can remove this one y limits and see like how it jitters and all those stuff. So this is how, yeah, I think it'll take some time to plot. Okay, so yeah, if you just look, yeah, initially look, our line is just almost 0 comma 0, right? Then it reaches the target and it just vibrates. So it reaches the target even before 40th generation, but still it will keep on mutating, right? So it just keeps on vibrating around this one, like our what to say, our the set of dots we have provided for training input and output. So you can also put like 100 generations or something like that, and it'll keep on vibrating round about near that line. Oops, is it wrong to put 100 generations? It's taking so long. Okay, yeah. Now look. It just keeps on vibrating near. Yeah. So that's how it is. So anyway, yeah, I think it would have been. I hope you like this video. So yeah, any kind of videos you want or something like that, you just please tell me. Next series of videos, I'm trying to put look into two things. One is analyzing the iris data set and all those stuff, where we'll be looking at data frames and all those things, and possibly some algorithms to predict it and all those things. And That's how it is. And I'm also looking at entropy and decision trees and all those stuff. I don't know what I'm going to put in my blog and what I'm going to say next. Okay, so, but yeah, subscribe and keep watching so that you'll get to learn data science from scratch. Okay, so that's the thing. Okay, so I hope, yeah, you're learning. Anyway, thanks for watching. Bye.